alkane is going to undergo rearrangement. Is it clear? So that is pH CH plus CH2 CH3, and finally your OH is going to come here. So what's the IUPAC name of this alcohol? Yeah, tell me.
1-phenyl propanol.
Yeah, 1-phenyl propane 1-ol. Correct. And suppose if you would have taken mercuric acetate, okay, water, that is the method for oxymercuration demercuration. That's what we discussed last time. NaBH4 and NaOH. So still the addition is going to be Markovnikov addition. H is going to come at the position where more H are there. But the cation will come here, but it will not undergo rearrangement. That's the only difference. So you are going to get option A as the answer. Okay? Is it clear?
Yes.
But is there any way by which you can get C? So what type of addition is C? What mode of addition you are observing in while you are forming C?
The anti-Markovnikov, sir.
Yeah, anti-Markovnikov. So anti-Markovnikov can be done by hydroboration and oxidation. Is it clear?
Yes, sir.
And what you take in hydroboration, what are the reagents? What is this? I call it as HBO. From the name of the movie channel, just to make you remember, HBO, hydroboration oxidation. Okay, so what are the reagents? What you can see here? What is this?
Diborane.
Yeah, this is diborane, and actually the diborane is actually comes in THF. THF is cyclic ether tetrahydrofuran. Okay, and this is how it commercially. So it is written. You will find in NCRT only they have given B2H6, but in all the competitive examination you will find BH3THF and H2O2OH minus, right?
What is the other thing, sir? BH3 THF.
Yeah, THF is the solvent.
Yes, sir.
And followed. So this step is, so it consists of 2 steps, and the name also indicate the first 2 letters is hydroboration. That is actually the addition of hydrogen and boron on the double bond. That is hydroboration. And the second step is oxidation. So that oxidation is changes the boron to OH. So finally ultimately you have H and OH connected. But the mode of addition get reversed. Is it clear?
Yes, sir.
So hydroboration, borane, THF, right? Followed by NaOH and H2O, peroxide. But most of my students say peroxide. So peroxide, okay, that happens in the presence of peroxide, but first you should say hydroboration, then, because in peroxide if you add HBr, the HBr will get added in the reverse manner in anti-Markovnikov fashion. If you add if you do the hydroboration and then do peroxide and OH minus, then water will get added in the anti-Markovnikov addition. Is it clear?
Yes,
So, yeah. So you will get one all, or the OH is connected on the outermost carbon of the double bond. Is it clear? So
Yes, sir.
yeah. So let's do this problem. So first we should understand the purpose of the reagent, what are the reagent, how to write the product without getting into the mechanism. Okay, there are two types of question. There are questions which are related to conversions, okay, and there are questions related to mechanisms. So if the question is related to conversion, just you need to know the reagent, you need to write the answer carefully, okay, and you will get the correct answer. But if the mechanism, if the question is based on mechanism, then you need to go get into the mechanism. Is it clear?
Yes, sir.
So that is the important thing which you should keep in mind while considering this. Yeah. So what's going to be the answer to this one?
So B, sir.
Yeah. So propane one all means OH is on the outer side, means it's anti-Markovnikov addition. So it is hydroboration followed by oxidation. Okay.
So basically, if you want to add hydroxyl group on the outer carbons, then you will use hydroboration oxidation.
Yeah,
But
exactly.
if it is inner mass, then you will use acid catalyzed hydration.
Yeah, yeah.
Yes,
Internally,
sir.
if you want to add, then you will use acid catalyzed, but that may go move further internally if you have, if the rearrangements are possible. Is it
Yes,
clear?
sir.
So now this thing. So how it happens? So first of all, the boron and hydrogen are added to the double bond. Is it clear?
Yes, sir.
But the addition itself is anti-Markovnikov. It is because the boron, being larger atom, will prefer to connect itself to the outermost carbon. Clear?
Yes, sir.
That is a reason why boron get connected. So H and BH2. Actually, the connection occurs simultaneously. That's why these dotted lines are represented. If this electron gets shifted on boron, taken by boron, these electrons get shifted in. So you have H and boron simultaneously connected on the two carbon atom, but boron will connect itself to the outer carbon. That's the key thing. Another thing is the boron has three hydrogen. So it is not going to just connect one time. It can react with two more time. So you can see here two more alkene molecules are written because the BH2 is going to come and will react with further with two more alkene molecule, and that's how you have this. But the pattern will be same. No, whether you uh, get into the detail or not, just the boron is going to get connected out on the outer carbon. Is it clear? Okay.
Yes,
Now
sir.
this is hydroboration. This is hydroboration. Now the hydroboration, the boron can be oxidized by using NaOH and H2O to OH. So ultimately you have a hydrogen and boron connected to both the carbon atoms. Okay. So the reason actually is because of the boron. So that is the mechanism. Okay. So let's do this question.
Sir, option B, sir.
Last option B is, this is B. This one, you are telling B or D? Second option
Sir,
or the
B, sir.
last option?
Second answer.
Second
Second.
one. Okay. So A is Markovnikov, yeah, true. Because A is by oxymercuration and demercuration. And B is anti-Markovnikov, that also is true. Because it is by hydroboration and oxidation. Yeah, so this is the right answer. What is the IUPAC name of B? Yeah, tell me. Yeah.
Sir,
What's the IUPAC name of the product
sir,
B?
3,3 dimethyl butanol.
Yeah, butane 2-ol. Butane
Yes, sir.
2-ol or 1-ol?
One also. B.
1-ol. Yeah. 3,3 dimethyl butane 1-ol. Right. Okay. Yeah. So let me just ask you one more problem. You know what is D? What is this? Tell me. Yeah.
Sir, BD3 is like diborane, sir.
Yeah, it is iodine, but instead of hydrogen, you have deuterium, which itself is hydrogen, and but the heavier isotope. This is just a labeling technique. Clear? Just to, yeah. So what you are going to get?
No, it reacts the same way like diborane.
What's going to be the answer to this?
Sir, is it one?
You need to check the isotopes. Actually, all are same only. But you need to tell me more specifically where the H is going to get connected, where the D is going to get connected. This is mechanism based question. Right?
Yes, sir. Sir, but this new reagent is like this reagent is like diborane, or is it?
Yeah, it
This,
is same as that of diborane, and these are hydrogen, heavier hydrogen.
okay, sir.
But you need to tell me where the heavier hydrogen having mass double. That's why it is called deuterium. Where that deuterium is connected and where the OH is connected. So this is mechanism based question. So actually you took BH3 instead of BH3. You took BH3 only, but with deuterium which is having hydrogen BD, you took this one. Okay. And actually what happens here is, so D is connected inside, BD2 is connected outside. CH3, CH, D, C, this is CH2 and BD2. Do you agree with this? This is the first step.
Yes, sir.
And finally, this boron will be replaced by OH. Because here you have not taken any deuterium. Can you notice it? Right?
Yes, sir.
So what happens here is, so very simple. So actually here the hydrogen, instead of hydrogen you attach D because it came with the boron. And finally you have BD2 and BD2 you replaced it by OH. So what's going to be the answer? Second option. Clear?
Yes, sir.
Okay, good. So this thing you should keep in mind. So suppose if the mechanism comes to the mind, if the mechanism comes to your question, you need to have the this question is related to mechanism. You need to have the mechanism in your mind so that you can answer it properly. Okay.
Yes, sir.
So let's move on to the another method for the preparation of Grignard. That preparation of alcohol, that is by Grignard. Okay, what are Grignard reagents? First, tell me this one.
So there are compounds that contain carbon metal bonds, and
Yeah,
it is from reaction of alkyl halide with alkyl halide with magnesium in
yeah,
triethylene.
yeah. Exactly, exactly. So alkali and magnesium. So these fall under the category of organometallic compound. Okay, what are organometallic compound?
Compounds containing carbon and metal bonds.
Yeah, compound containing carbon and metal bond are organometallic compound. So which of the following is an organometallic compound? more than one correct option. Yeah.
Sir, option one, sir.
Yeah, option 1 and option 4, both. But these two are not organometallic compounds. Why?
Sir, because here the carbon is connected to the metal by oxygen.
Yeah. So metal is connected to oxygen, it is not connected to the carbon. Is it clear?
Yes, sir.
So this is very, very important. There are many other type of organometallic compound. So this is organocopper, carbon copper bond is there. Okay. And this is carbon and cadmium bond is there. Okay.
Yes, sir.
So this is all these are organometallic compounds. Grignard is also one of them, and it is prepared by so all the reaction can be carried out if you know this thing. And what is this?
Sir, that's the mechanism.
That is
Sir, that can you show
yeah,
what you're
yeah,
fighting is?
yeah. Actually, the metal is positive, electropositive. Its electronegativity is 1.2. And carbon is more electronegative. That's why this bond has acquired polarity. Clear?
Yes, sir.
So that is why you have minus charge on carbon. So whenever you think of Grignard, think that the carbon has minus charge. It is a nucleophile. Okay, clear?
Yes, sir.
Now next thing is, if it is a nucleophile, so you can prepare very easily. And suppose if you have, so what's going to be the answer here? You need dry ether. Ether should not contain any moisture or alcohol. Why?
Because it is very reactive and it will react even
Yeah,
with
yeah, exactly. So whole your Grignard is going to get spoiled if you have that water in it or alcohol in it. So you should not have any compound which has acidic hydrogen in it. Okay, clear? That is very
yes, sir.
important. So now the next thing is, Suppose if I have taken 1 mole of Grignard, where the Grignard is going to form? In the last question. This one. Yeah, tell me. Yeah, Nabil. Where
Yes,
the which one, the bromine or fluorine? Which one is going to form Grignard or both?
for bromine,
Which one is going to form? Am I going to make MgBr or MgF or
for
both?
MgBr, sir.
Yeah, MgBr. Why?
Because fluorine is very reactive.
So the if fluorine is reactive, it should react. Then why we have made MgBr? Actually, the bromine is going to be more broken more easily than the fluorines. This bond is smaller and stronger. Is it clear?
Yes, sir.
And if it is smaller and stronger, what it means? It means that it's not going to react. So first of all, the iodine react, then bromine, then fluorine, then iodine. Is it clear?
Yes, sir.
Yeah. So that is the reason. So if you have options given, you need to check which one is going to form the Grignard. Now the next thing is what Grignard can do. Yeah, you can tell me. What Grignard can do.
Sir, it will join with the carbon, it will join with the alkyl group in the alkyl halide, and it will lead to the removal of
Yeah,
the
yeah,
side atom.
yeah. Actually, the Grignard is just now I told you the Mg is going to be plus and the Grignard is going to be minus. So this will act as a nucleophile. It will go and attack on the carbon atom, on any other carbon atom or any other atom, not only carbon, which has positive charge in it. Is it clear?
Yes, sir.
So, so if you have taken aldehyde and ketone, this R dash minus is going to come and attack on this. So why the carbonyl is going to get attacked? Why the CO of aldehyde and ketone will be attacked? What's the reason?
Sir, because it is a polar bond, sir. In that case, carbon will have.
Yeah, exactly. It's a polar bond. In this case, the carbon is partial positive, while the carbon of your grignard is negative. So it is going to come and attack here. And if the nucleophile is coming, bringing in its own pair of electrons, what is going to happen? The pair of electron which is already present on the carbon atom is going to get pushed away. Pi bond is will be pushed out on the oxygen. Is it clear? So oxygen now will be minus charge. Can you see this?
Yes, sir.
So this is nucleophilic addition reaction R, right? And this you are going to get. Okay. So suppose if you react with a formaldehyde, if you react a grignard with formaldehyde, what type of alcohol you can get? In words, can you put up this thing?
Yes, sir.
Suppose if you react a grignard with a formaldehyde,
So then, with the formaldehyde, you will get primary alcohol. With other aldehydes, you will get secondary alcohol. You will get tertiary alcohol.
yeah. For formaldehyde, we are going to get primary alcohol with one more carbon. Okay, yeah, good. So suppose if you want to make, suppose if I have benzene, so let's answer this question. What is D?
Alcohol.
Yeah, which alcohol?
So primary alcohol.
Yeah, primary alcohol. What's the name? pH.
BH2OH.
Yeah, benzyl alcohol. That's the common name. Clear? Right? So benzyl alcohol. Suppose if I ask you, so what is this compound? Yeah, Nabil. Which compound is this?
Sir, is it tyrant?
It is ether, cyclic ether. It is known as ethylene oxide. Because it is prepared from ethylene. And the other name is your oxygen. Is it clear? So what's going to happen if you react a grignard with this? Yeah,
So that oxygen atom is being shared by the two carbons.
Yeah, it's connected to two carbon and forming a ring, cyclic ring. Yeah. So this is going to come and attack on the carbon, because carbon is having partial positive charge, oxygen is having negative charge. Is it clear?
Yes, sir. So
And
then have partial positive, right?
pardon?
The other carbon also have partial positive charge,
Yeah,
right, sir?
also. Yeah, but both are same. But if they
Sir,
are
then
different, then we are going to choose the one which is less branched, because this
yes,
is
sir.
SN2 reaction.
Yes, sir. Sir, in the reaction, then, like if one molecule is attaching to one carbon, then the other
Yeah.
Grignard won't attach to the other carbon as well simultaneously.
No, 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 no. Why it will not happen? Let me tell you. Actually, do you know the Grignard itself is prepared in a ether? Okay. And what that
Yes,
ether is cyclic ether, THF or diethyl ether. And this also is an ether. But why, what is the reason that there in the original preparation of ethers, of Grignard in ether, the Grignard has not reacted with that ether? But in this case, I am taking ether not as a solvent but as a reactant. Means actually the ether is reacting with the Grignard. So what is the root cause for the reaction of this ether? Yeah, tell me. So what's the root cause? Then you are using the two accounts, right? Nabil,
yes, sir.
yeah, you are using the two accounts. Actually,
Can you repeat, sir?
yeah, actually you are logged in by two devices.
Yes, sir.
Yeah. So what happened?
So sometimes the device doesn't work. So in
Yeah,
that case, I can shift
yeah.
fast.
Okay. So what is the answer? What's the reason actually? The reason is actually the angle strain. Okay. What's the angle strain is? What is angle strain?
Small angle.
Yeah, it is a small ring, and a small ring, because of the small ring, it is under the pressure. It is under pressure. Okay. Is it clear?
Yes, sir.
And because it is under the pressure, so it will open up. So what you are going to get here? pH. This is going to break away like this. Getting it?
Yes, sir.
Okay. And this is going to become OH, right? After hydrolysis. In the last step, you put H plus H2 also. So if you want to make an ether which is having two more carbon atom, if you want to make an alcohol with two more carbon atom, what you need to do, you need to take CH2, CH2. You need to take CH2, CH2O. That is actually the ethylene oxide. Clear?
Yes, sir.
Okay. So what happens if you take other aldehyde, ketone? Ketone, you are going to get tertiary alcohol. With any other aldehyde, you are going to get a secondary alcohol. With CO2, you are going to get a carboxylic acid. Okay, that you know already, right?
Yes, sir.
Yeah. Okay. So let's do some questions.
What is PI2?
Red phosphorus and I2, iodine. Here, red phosphorus and iodine.
Yes, sir.
Yeah. Tell me.
Sir, what will happen if it is in phosphorus and iodine, sir?
This we have studied in alkali chapter. Phosphorus and iodine is nothing but Pi3. Now can you
Uh,
tell me
yes, sir. Yes, sir. Yes, sir.
what we are going to get?
Sir, we will first get a Grignard region that will
No, no,
react with
not. Yeah, where we are going to get is A a Grignard reagent? What is A?
CH3, CH2I, sir.
Is yeah, it is iodide. Then you are going to get a Grignard. Yeah. Then you will react. Then you have reacted with formaldehyde, right? And finally you have reacted with water. So ultimately, what's going to be the final answer?
Sir, C.
Answer is going to be option C. Correct. Right. Good. And this is some different question we have not discussed. This is not related to alcohol, but related to Grignard, but very important. Yeah. Yeah, Nabil.
Sir, how do we know which bond will undergo cleavage, sir?
Yeah, actually, I can give you a hint, and that is alkynes have acidic hydrogen. Terminal alkynes.
Can you repeat, sir?
Terminal alkynes have acidic hydrogen. Why it is acidic?
Because it can release the hydrogen.
Yeah, but why it will release? Why not any other?
Because the carbon hydrogen bond is weak.
Yeah, but actually, yeah, this is sp hybridized. This is electronegative.
Yes, sir.
Okay. So now tell
Yes.
me, right? You must have studied in your 11th class. So 11th also, where you studied actually? Learnivio.
No, sir.
Right now you are in uh, Dubai,
Yes, sir.
right?
How this?
Yes, Saudi. Okay.
Sir, it will produce B, sir.
Yeah, so this is, I told you, just keep in mind this, you will do this all. What is going to be the answer to this one?
Sir, B.
Second or fourth option? Which one?
Second one, sir.
No, not second one. This one, D. This is minus, this is acidic hydrogen. It is going to abstract this.
Yes, sir.
Clear?
Yes, sir.
So it is going to be option D. Acid-base reaction. So I hope it is clear. And just remember when we discussed one thing, we discussed that actually your ether should not have any alcohol or water. Why?
Because it is very reactive.
Yeah, it's very reactive. The same type of reaction would have happened. And
Sure, sir.
yeah, your Grignard would have changed to alkane.
Yes, sir.
That's why we are not taking. Okay.
Yes, sir.
So what's going to be the answer to this one?
Sir, 3 methyl, 3 hexanol means, uh, sir, is it 3 methyl hexane, sir?
Hexane 3 all.
Okay, sir. Sir, is it A, sir?
3 hexanol and CH3. 3 hexanol. CH3 MDI. Yeah, A. Right? Correct?
Yes, sir.
And where else the Grignard can add? What will happen if the Grignard add to carboxylic acid derivatives? Yeah, tell me.
Sir, can you repeat, sir?
So what will happen if you react a Grignard with ester or acid chloride?
Sir, the carbon oxygen double bond. Sir, in the carbon which is attached to the oxygen via double bond, the
Yeah.
alkyl group of that region will attach, and that carbon oxygen double bond will become a carbon hydroxyl bonded
Yeah.
group.
Suppose if you have 1 mole of this and you have X moles which react with this. So what is the value of X?
Or one,
Yeah. 1 or 2?
two, sir.
Yeah, X is 2. Why 2?
Sir, because it is having two alkyl groups and 1 mole of each
Yeah,
pregnant region.
actually, first of all, what happens when the methyl comes, O minus forms, it breaks away and let's push it out the OR dash. Okay. This is how the first mole has happened. Okay.
Yes, sir.
Yes. So now the thing is, so is it going to stop here? Or so OR is pushed out and CS3 is attached. Is it going to stop here or one more time is it? So and you ended up with a ketone. That's what you can see. So what is going to happen if you have one more?
It will react with the other alkyl group as well.
Yeah, that is going to come and join, right? And now nothing is going to come out because all are carbon, and this is will be there. And if you take the react it with the H plus, it will going to become here.
Yes, sir.
And same thing happens with your acid chloride also. So what is going to happen? Look here. So in the first case, the Cl got removed, one ethyl joined. You ended up with the ketone, second ethyl also joined. Right?
Yes, sir.
This is one or more than one, correct?
Sir, this attack of Grignard region takes place by SN1 or SN2, sir?
No, that is not substitution, that is addition reaction. Nucleophilic addition.
Yes, sir. So it does not depend upon any the stability of carbocation or anything like that.
It depends upon actually uh, how big the groups are. Actually, that will make the additions lower. But Grignard actually, in fact, is very reactive, so it is not going to get affected. It will add, right?
Yes, sir.
So, what's going to be the answer to this? Yeah. So, I can tell you this Grignard can be this. This is a tertiary alcohol. And the tertiary alcohol can be prepared by taking a ketone and a grignard. Now you can tell me how it is going to form.
Sir, can you repeat, sir?
Actually, this is a 3-degree alcohol. Okay. And 3-degree alcohol, it is going to form by C6 or ketone and grignard. So which ketone and which set of grignard will you take?
Sir,
So
is
that
it
you get
C?
it is more than one,
C?
correct. See, you have phenyl group, yeah, ethyl group, okay, and methyl you brought in with the help of grignard, correct. Yeah. Can A be the answer? A.
Yes, sir. Sir, why can't B be the answer, sir?
Yeah, this can also be the answer. Yeah, this can be the answer. D can't be the answer. Right? Why? Because
Why,
you
sir?
are taking, yeah, one alkyl, one pH is there, and ethyl is going to come, and no other alkyl group is given in the, so ethyl is going to, only ethyl is going to come and join itself 2 times. So which tertiary alcohol you are going to end up with
Sir,
in
so A, B,
this?
and C can be answers, only D can't be.
Yeah, A, B, and C will be the answer. D cannot be the answer. Here,
Yes, sir.
okay. So this is, we discussed already this one. Just a question on that.
Sir, C.
C will, no, this one. C will have only one carbon.
Sir, then A, sir.
A, but that will be secondary alcohol. This is a secondary alcohol. Okay. Here. So what the question is, yield a primary alcohol containing 2 more carbon.
Then B, sir.
Yeah, B is the right answer. Correct. What about this one? Yeah.
Sir, is it D, sir, the fourth option?
2-phenylethanol can be prepared. 2-phenylethanol. What is 2-phenylethanol? Is it clear?
Yes, sir.
Yeah. Tell me. What's going to be the answer?
Sir, the fourth option.
Fourth option, no. Because if you take the fourth option with phenyl magnesium, pH is going to come here and you are going to get this with the fourth option. Is it clear?
Yes, sir.
So there is a difference in this one and this one.
Sir, then C, sir.
Option C, yeah, that is the right answer. Correct. Good. So the next way for the preparation of alcohol is by catalytic hydrogenation or by reduction. And the most common way to do the reduction is by catalytic hydrogenation. Okay, what you take in the catalytic hydrogenation, tell me.
So we will take aldehydes, ketones, carboxylic acid, and
Yeah,
the catalyst is like nickel, palladium, platinum, and we will hydrogenate those carboxylic compounds with
yeah,
hydrogen for those metal catalysts.
yeah, yeah, exactly. So nickel is very reactive. Nickel, platinum, palladium, you take, and from that you get them. So which type of alcohol you cannot prepare by catalytic hydrogenation reaction?
So tertiary.
Yeah, tertiary. Why? Because the tertiary do not have hydrogen on the tertiary carbon. Actually, whenever you're doing the reduction, you need to have a double bond. And the double bond cannot be there on the tertiary carbon. Okay, clear?
Yes, sir.
Okay, that is the reason why you can't have your tertiary alcohol can prepared directly by your reduction. So what about this one? This is also same. Okay, NaBH4 is weak. It is not going to reduce the NaBH4, right? And LiLH4 and NaBH4, what's the characteristic? What
Sir,
type
they
of
are
bonds are not reduced? Yeah, they are.
will donate hydrogen.
Yeah, they are hydride donor. They are different kind of reducing agents. They are hydride donors. Okay, they give H minus. So that is nucleophilic addition reaction, right? So and both LH and NaBH4 will not reduce the alkene and alkynes. You can see over here. They are intact,
Yes, sir.
right? Alkene and alkynes are not reduced, and NaBH4 can reduce only aldehydes and ketones. That you know. Is it clear? While
Yes, sir.
LiLH4 is a strong reducing agent, it can reduce all the aldehydes, ketones, and all carboxylic acid derivative also can be reduced by it. So, yeah,
Sir, A is two alcohols.
yeah, two alcohols. Correct. Right. So you are going to get an ester. Ester will get reduced. And this is going to break away, and you are going to get two alcohols. The two alcohol may be same or different. That you need to check the number of carbon atoms. Okay, that will help you to know whether they are same or different. Right?
Yes, sir.
So let's do this question. So LAH can reduce not only aldehyde, ketone, all the polar pi bonds can be reduced.
Sir, is it the fourth option, sir?
It is fourth option. Yeah, correct. So you will have get CN attached, and what will happen with this when you do this second step? It is going to be carboxylic acid. Okay, and when you react it with LAH, carboxylic acid is going to reduce with 2OH. Okay, clear? Right? Okay. So preparation of aromatic alcohol. This we have seen. Just we will quickly go through it. So can you tell me how can you convert benzene to phenol quickly?
Sir, we treat with oleum and then uh, we first treat it with oleum and then we treat it with
Yeah,
with
oleum and
sodium.
yeah, anyways, yeah, that is NAS. Yeah. Or you can make it yeah, it's same actually. You can make it chlorobenzene and then you can use Dow's process. Okay, Dow's process you can use NaOH.
Yes, sir.
That you can. Right. And NaOH, what about this one? This is the you have more and more NO2 group. It is going to make faster. That's what we discussed. So I hope this is clear, right?
Yes, sir.
This is you were talking about this
Yes, sir.
sulfonation and followed by biomolecular nucleophilic aromatic substitution. Yeah. And how you prepare by diazonium?
Sir, we heat the diazonium salt, sir.
The diazonium salt with what?
We heat it, sir, at
Heated with what?
298
Yeah,
Kelvin in presence of water vapor, I guess.
actually, it is heated with steam or dilute H2SO4, right?
Yes, sir.
And that is going to, the N2 is going to come out. It is a very good leaving group, and OH is going to come in. This is SN1, right? And this is cumene hydroperoxide method. Okay.
Yes, sir.
So in cumene, what is cumene?
Sir, isopropyl benzene.
Yeah. And how can you prepare it from benzene? Because they give you the preparation of cumene also, not directly cumene.
Sir, by using Grignard reagents.
No, not by Grignard. Actually, in benzene, always remember that nucleophilic, electrophilic aromatic substitution. So if you have this, how you are going to end up with the cumene? Tell me.
Uh, Sir, the carbon-carbon double bond will break
Yeah, but
because
how?
I don't know, sir.
Yeah, you need to make it as cation. Okay, that is very important. So how can you bring in the cation here? You can take concentrated H2SO4 or just write H plus. So H plus is going to come and join in on this, right?
Yes, sir.
And in the Markovnikov fashion, and you will have a cation in the middle. Okay, then what will happen? If you have a cation in the middle, and this cation is going to go and attack on the benzene ring. Clear?
Yes,
And
sir.
that's how it will get connected to the benzene. Or you can start with Fidelcraft reaction. Okay. So let's do this.
CH, sir, benzene ring with a CH, but with a whole cumene structure, but instead of the hydrogen, we have like a carboxyl group, sir.
Yeah, yeah. So what is going to be the answer?
Sir, the option C, sir. Third one.
Yeah, option C. Right. Cumene hydroperoxide. This is hydroperoxide. Okay. What about this one?
Sir,
Yeah.
sir, is it A, sir?
No, that's what you should keep in mind. Always, this is the carbocation which is going to form. Clear?
Yes, sir.
After the removal of Cl. In carbocation has a tendency, always you should remember what that tendency is. In today's class, also in the first thing which we discussed was that one. We discussed the method for the preparation of alcohol by 3 different ways. So wherever the carbocation is forming, actually that you need to check that whether it can rearrange or not. Okay. And if there is a possibility of rearrangement, then what you will do? Yeah,
Shift the
Nabil.
carbo.
Yeah, you will shift because each shifting take 10 to the power minus 6 seconds. Yeah. So always keep in mind that you will do the rearrangement. Okay. So you have primary carbocation, and you know the carbocation secondary is more stable, so it is going to get shifted. Okay.
Yes, sir.
So now tell me the answer. Yeah.
Sir, is it C, sir? I mean D.
Yeah, that is the answer. Yeah, that is cumene. Cumene only, right? C and but C and D both have cumene. And now tell me. Actually, most of the people forget what is the byproduct. Okay. You need to concentrate on the byproduct also. A lot of question in JEE advanced also they have given on the byproduct. So what that byproduct is, which is formed with phenol. Everybody remember that it is the method for the preparation on phenol, and the phenol is going to form. Clear? Yeah, tell me
Yes,
now.
sir. Sir, then acetone will be the byproduct, sir.
Yeah,
D.
acetone is a byproduct. Yeah. Yeah. So D is the right answer. Okay. Right. So let's cover this in the next one, acidic strength and all. Okay. So this today we discussed a lot of important point about the grid guard and so just these are the important points where everybody makes mistakes and for example in the acetone is a byproduct. Everybody actually forgets this. Okay. So in JEE also JEE advanced they have given that acetone questions regarding acetone. Okay. So just go through it, just revise it, and let's meet it on the next time with more questions.